Alright, here we go with objective 30, determining the graph of a line using x and y intercepts. So we did this in the previous objective, but I gave you the x and y intercepts. Now I'm going to give you the equation, and we're going to have to find the x and y intercepts, and then we can graph it the same way. So as a reminder, as a quick recap, our x-intercept is where the line crosses the x-axis. So our x-intercept is where the line crosses the x-axis. Likewise, our y-intercept is where the line crosses the y-axis. And I alluded to this in the previous objective notes, how to find these intercepts algebraically. So the x-intercept, to find the x-intercept algebraically, we have to set y equal to 0 and then solve for x. And that should make sense. When we picture the x-intercept on the graph, it's where the line crosses the x-axis. Well, the y-coordinate at the x-intercept is 0. So that's why we set y equal to 0. Likewise, to find the y-intercept algebraically, we set x equal to 0 and then solve for y. And the same is true. So at the y-intercept, the x-coordinate is 0. All right, so now I've got an equation, y equals 2x minus 4. You might immediately recognize this is in slope-intercept form, but we're gonna graph this using intercepts instead of graphing how we have in the past. So we're going to start with the x-intercept, and as a reminder, that is where y equals 0. So we're going to set y equal to 0 and then solve for x. So in this equation, y equals 2x minus 4, we're going to set y equal to 0 and then solve for x. So everywhere we see y, we're going to plug in 0. All right, so to solve for x, we add 4 to both sides, and we have 4 equals 2x. And then our last step, we divide by 2. So we have x equals 2. So as an ordered pair, our x-intercept is 2, 0. Now let's find our y-intercept. And as a reminder, that's where x equals 0. So to find our y-intercept, we're going to set x equal to 0. So we have y equals 2 times 0 minus 4. Y equals, well, 2 times 0 is 0. We'll bring down the minus 4. And then 0 minus 4 is negative 4. So we get y equals negative 4. So as an ordered pair, our y-intercept is 0, negative 4. So using these 2 points, our x-intercept and our y-intercept, we can graph the line. So our x-intercept, 2, 0, means we go right 2 from the origin. Our y-intercept, negative 4, so we're going to go down 4 from the origin. Use a straight edge, a ruler, ID, anything like that. And we graph the line. All right, let's try one more. Here we've got 2x minus 4y equals 12. This equation is in standard form. We're going to talk a little bit more about standard form later on in this unit. But let's go ahead and find the intercepts of this. So to find the x-intercept, we set y equal to 0. So we're going to plug in 0 for y. So we have 2x minus 4 times 0 equals 12. And by the way, notice anytime I'm substituting, I'm using parentheses. All right, so to solve for x, we're going to do 2x and then negative 4 times 0 is 0. So we could say minus 0 equals 12. Well, 2x minus 0, well, that minus 0 doesn't change anything. It's still 2x. So we have 2x equals 12. And then our last step, we divide both sides by 2. So we have x equals 12 divided by 2 is 6. So as an ordered pair, we have the x-intercept of 6, 0. To find our y-intercept, we set x equal to 0. So we have 2 times 0 minus 4y equals 12. Well, 2 times 0 is 0, and then we'll bring down the rest. Minus 4y equals 12. Well, 0 minus 4y is negative 4y. We can drop that 0. And then one more step, we're going to divide both sides by negative 4. So now we have y equals, well, 12 divided by negative 4 is negative 3. So we've got a y-intercept of, as an ordered pair, 0, negative 3. All right. So we're going to go ahead and plot each of these points. So 6, 0 is our x-intercept. So we're going to count right 6. And then our y-intercept is negative 3, so we're going to count down 3. And we're going to connect our dots. That gives us our line. And we get this line here. All right. Real quick, I do want to mention, too, this technique that we've learned, solving for the intercepts and using the intercepts to graph, that works for any line. So, if it's in any form for any equation, this technique works. So this is an extremely useful tool that we're going to be using throughout this unit and throughout the school year. All right. As a reminder, too, the x-intercept, we set y equal to 0 and solve for x. The y-intercept, we set x equal to 0 and solve for y. We're going to get some practice on this, so we'll see you tomorrow in class. Have a great day.